Hi guys, Rishabh here. So today we are discussing the topic binary search. Before discussing binary search, let's discuss little bit about linear search as well. Why is that so? You will get to know that later, right? So what is the linear search? You are given with an array, right? And you are given with an element as well. What you have to do, you have to just find that element in the array. And if that is found in the array, you just have to return the index of that particular element, right? And if that is not found in the array, you just have to return -1. Generally, we will do this in the case of linear search. Now, we will see why we need binary search, right? What is the intuition behind binary search, right? Well, if we already have linear search, why we are going towards the binary search, right? We will see all that thing in the upcoming session, right? So let's try to understand a little bit more about this in the whiteboard. So I'm just sharing my screen. Yeah. So today we are going to discuss binary search, right? Now, as I already say that before discussing binary search, let's discuss a little bit about the linear search as well. So what's the linear search? Let's suppose we have some elements like 1, 3, 5, 7, 20, 25, and then 29, right? Let's suppose we have size of this array equal to n equal to 7, right? And I have to find the element 20 in this array. So what linear search would say? It would say just iterate over this whole array one by one, right? First, I will go here. I'll check if element 20 is equal to 1. Obviously, that's not the case. I'll just go on second element. I'll just check if 20 is equal to 3. That's obviously again not the case. I'll just move on to the 5. I'll just check if 5 is equal to 20. That's again not the case. I'll just move on to 7 and check if 7 is equal to 20. That's again not the case. Here, I'll just again check if 20 is equal to 20. Yeah, here we go. I just got my element. So what I have to do, I just have to return this index, right? Return 4, right? So how I will return this element? I'll just iterate through this loop, something like this, int I equal to 0, and then I less than n and I plus plus, right? And I'll just return this I thing, right? I'll just compare with every element, and if that is matches with the current element, I'll just return the I in that case. This is my intuition behind linear search. And if what is the negative case here? Negative case is here is if we already traverse whole of the array, right? I already traverse whole of the array and I'm not getting this particular element in the array. In that case, what I will say? I will say that element is not existing in my current array, and we just have to return -1 in that case. So what I'll do, I'll just return -1 in that case. So this is the basic intuition behind the linear search, right? This is the basic intuition behind linear search. Now, why we need binary search? Why we need binary search? So intuition behind binary search is in linear search, what you are doing, you're traversing whole array. So let's assume an example. Let's suppose you have an array size of 1 lakh, right? 1 lakh. And element you're trying to search is placed at the last index of the array. So for that, what you are doing, you are traversing hell lot of the arrays completely to just find the last index of the array, right? That is not the good thing in my opinion, literally, right? So obviously the time complexity for that is order of n, right? The time complexity for that is order of n. So you're seeing right, I'm just finding a element in the whole array and I'm traversing whole lot of the array, right? That is not obviously good thing. So what I can do in that case is there the binary search would come to save us from this whole traversing of the array, right? Now, how it will, what's the condition binary search will come with? There is a condition like the array given to you must be sorted. If array is unsorted, you can't apply binary search on that, right? So very first condition about that is array must be sorted, right? Now, let's try to dry run on this binary search thing, right? And how our whole logic will work around this binary search. Cool. We already checked how linear search is working and what's the intuition behind the binary search. Now let's try to have a look on the little bit about the binary search algorithm. What exactly binary search algorithm is saying to me, right? So my array is again something like 1, then 3, then 5, then 7, then I have 20, 25, now 27, right? N equal to again 7, and I have to find this element that is 20, right? Now, what binary search says to me, I'll take an kind of 2-pointer approach, right? Or like starting from, take 2 pointers like at the starting at 0 and ending at n minus 1. That means start will start from here and end will start from here, right? And what I will check, I'll calculate the mid of this, both of the start and end. I'll take the mid of the start and end. So how I will calculate the mid of the start and end? It's very simple, something like start plus end upon 2. As simple as that. And what's the intuition behind calculating mid? You will get to know. You will get to know. So let's suppose in the very first case, my start will be at, I'm just making 3 columns so that we have better clarity like how this start, mid and end is working, right? So start, end and mid. S is start, E is end, M is mid, right? So let's start. Let's say I'm start with 0 and end starting from n minus 1, that is 6. So what I'll say, let's calculate M, that is mid. How I'll calculate mid? Start plus end upon 2, that is 0 plus 6 upon 2, that is equal to 3. So medium is 3, right? So 0, 1, 2, 3, 4, 5, and 6, right? So mid is something here at this point. So what you will check, just check directly if that mid index contains my element value or not. Something like this. If my mid element containing this element or not. If this is containing, you just have to return the mid pointer. You don't have to do anything, right? As simple as that. Now let's suppose there is another case. What is that case? The case is that, like, if that particular element that you are searching is greater than the mid element, like in current case, at mid we have 7 and we are comparing it with 20, something like this, right? And 7 is less than 20, and you already know that array is sorted. Then do you think there any sense to traverse on the left side, because all the elements is already sorted? And if I'm on mid, that is 7, then all the element left to the mid is already lesser than the 7, right? So we don't have to traverse on the left part of the array, right? So what I can say from here is, if array at mid is what? Less than my element, what I have to do? I just have to traverse the right part of the array. As simple as that. Now, so for that, I have to update my start with mid plus 1, right? Because I have to ignore the left part, because that is already lesser than the mid element and what I have to search in that array, right? Now, the third case is in any case, that element you are finding is less than the mid part. If that is less than the mid part, then you don't have to traverse on the right side, because on the right side, all other elements are greater than the mid elements, right? So in that case, let's suppose if array at mid is greater than the element that you have, what you will do, you will just update your end equal to mid minus 1, right? So these are the 3 cases that I have to check in the binary search. And if I am fulfilling all these 3 cases, that sums up the binary search logic. As simple as that, right? So now when I have to stop, that's the condition, right? Because we have to put some boundary cases, right? We have to end somewhere, right? I have to end this searching part, right? Somewhere at some point. So you can say that if my start index cross the end index, like start index is on 0 currently, end is on my last, when start index bypasses this end index, I will say my whole array will be already traversed. I don't have to traverse any other element. In that case, I can break the loop, right? And if I already got break the loop and I'm not getting any return statement from that loop, that means I'm not finding that particular element in the whole array. Then that means that is my negative case. That is, that element is not found in that particular array, and we have to just return the -1 in that. As simple as that. So negative case is I have to just return -1. Now let's try to little bit dry run on this particular example, right? So currently my mid is at 3 pointer, right? So my mid pointer value, that is 7, right? That is lesser than the 20, right? That is fall in the this category. What I have to do, start equal to mid plus 1, right? So mid is 3, start becomes 4, end will remain same. Now I have to calculate mid again. So 4 plus 6 upon 2, that will give me 5. Now mid is on 5. So I'll update mid. Mid is on 5. I'll also update start as well. Start is on 4. Now again, you have to check if if array of mid equal to element, that is not the case. Now what you will check, if array of mid greater than element, that is the case. Yeah, obviously that is the case. Like 25 is greater than 20, right? So this falls in this second case. What I'll do, I'll just update n to the mid -1, because all other elements at the right side of the mid, that is greater than the mid element, right? So we don't have to take care of those things. So what I'll do, I'll just put start as 4 and end as 4 as well, right? And what again, mid 4 plus 4, that is and upon 2, that is again give me 4 only, right? So my start pointer, end pointer, mid pointer, all are at the fourth pointer itself. Start, mid, end. Now what you will check, this if mid is equal to this particular element, yeah, that is equal. Now I got my answer. I'll just return 4 in this case, right? I'll just return 4 in this case. Okay. So I think this sums up the whole binary search logic. Let's try to do little bit coding on this part, and let's see how this whole of the logic going to be work for me. Okay. So I'll just write this scanner class to take the input. Now I have to take this an integer input from the user, right? Like how many elements we have in the array. Right? Before that, I have to declare the array as well in my code, right? And I have to take the input of the array elements, right? Now I already take the input of the n, already filled my array. Now I have to take the input of the particular element that we have to find in the array, right? Now I'll take element, right? Okay. Now here I will start writing my logic for the binary search. So for that, I have to take 3 pointers, that is start, that is equal to 0, and end, that will is equal to n minus 1, and mid, that is equal to, let's take mid as 0 for now, and I'll run a loop, something like this, if while s less than equal to e, right? Now after that, what we have to do, I have to just check, like if array at mid element is equal to the my current element, right? What I have to find, right? In that case, I just have to return. I don't have to return anything. I have to basically print, because we have a main function, and that main function contains a return void type. So let's try to print. But before that, doing that, what I have to do, I have to update the mid pointer as well, right? So mid equal to what? Start plus end upon 2, right? I write the very first part of my code, right? Now the second condition is, let's move on to the second condition. What my second condition is, if array of mid greater than the element, right? If array of mid greater than the element, in that case, what I have to do, I just have to make end equal to mid minus 1, right? And in all other cases, we just have to do start equal to mid plus 1, right? So yeah, and let's suppose if I'm not getting any print statement and I'm not returning from here, this statement, that means and this this loop will already get break, right? Then what I will say that I'm not able to find that particular element in my array, right? So in that case, I just have to return -1, as simple as that, right? Yeah. And I think this sums up my whole logic of the binary array. Let me go through the code once again. What we are doing, I'm just taking n as an input, that is the size of the array, and I'm declaring this array with n variable, and I'm just iterating over the array and taking input from the user for that particular array, and I'm taking the element as an input that we have to find in the array. And after that, what I have to do, I just have to check like until s less than equal to e, start is lesser than my end. I have just have to check like if my mid element is equal to the element that I have to search. If that is the case, I have to just print the statement and return from it here, right? And I have to just move out this mid statement, finding the mid statement at the top of the one, so that it can update for all the cases. And again, like if that is not finding my current element is not at the mid pointer, what I'll do, I'll just check like if my current mid element is greater than the element that you have to search. Uh, there is no sense of going in the right direction, right? We just have to find in the left one. Otherwise, we have to find in the right one. So that will the whole logic. Let's try to give the input to this. My n equal to 7, then 1, 3, 5, 7, 20, 25, 27. This is my array elements, and what I have to find, I have to find 20 in this, right? So my code should be give the output of 4 only, right? Let's try to run and cool. That is what we are expecting from our code. That is 4. Now let's try to replace the input, like instead of 20, let's try to search that is not in our array, right? So instead of 20, let's try to search 21. What I'm expecting here is -1. Let's see my code is giving -1 or not, right? Okay, cool. So that's what we are expecting, and my code is running as perfect as like binary search. So this whole sums up the logic of the binary search. I think we discussed about the linear search first, like why we are using binary search instead of linear search, and what's the condition of the binary search. We tried run the code like on a particular case, what's the negative case, and also we already tried running the whole code on a particular case, for the positive case as well, for the negative case as well. Hope you like this session, guys, and we will meet in the next session. Till then, goodbye. Thanks.